the number one question I would say that I get is, I've got a fossil fuel based system. How am I going to make that into a heat pump kind of system? And so we've tried to address those problems. I challenge you to keep asking us some of those tough problems and telling us your stories around that. We're probably not perfectly there yet, but I think we're making good progress in thinking about these different pieces. We did start with this with our kind of priority waterfall, and in terms of energy efficiency really being kind of the first step. And some of that is that if you start by fixing the envelope first, looking at the plug loads, looking at the lighting loads, before you start thinking about what that HVAC needs to look like in the future, that will really help inform it and may shift it and may actually put some things over the top to make heat pumps much more realizable than you thought were available. And so that reduction in size makes a big difference, because one of the barriers we hear is electrical capacity. And certainly reducing the loads helps that electrical capacity. Once you get through all that and just going through the rest of these pieces, being able to match that with on-site renewables, and the grid interactivity is more aligning those loads with available renewables. I often have said that if we could make buildings use more energy between 10 and 2 every day and no energy the rest of the day, the utilities might respond by putting more renewables on the grid, especially solar, because it's available, and you could better use that resource. Offsite renewables, and then finally the notion of buying offsets or certificates of some sort. But we do get a lot of questions, right, on how to electrify that, fossil fuel equipment with some kind of heat pump technology. So next slide. So just in terms of kind of the energy breakdown, and I sometimes think this surprises people as the building loads have gone down, especially in newer construction, and we've really gotten a handle on the heating and cooling, getting that lighting load down. When you look at a typical commercial building today, it's made up by plug and process loads. And I encourage you to listen to the recording of the last peer exchange that we had, if you weren't there, on plug and process loads. Because again, if you can make that section smaller, along with all the other pies, it really does impact what that HVAC looks like. But on the other side of it, when you add up the pieces, still a third of it is for HVAC. And a large component of that HVAC is treating outside air. And I think that's the next thing that surprises people, is what percentage, the high percentage of HVAC energy that goes into thinking about treating outside air. I also like to ask the question, like, well, why do we even need HVAC systems? I mean, kind of a long-term goal would be is that the rest of the building is so good and so energy efficient that maybe we don't need heating and cooling systems. And that actually is kind of an interesting way to think about the problem, is that you just need it to make up for what the envelope can't do in your building. And at the end of the day, it's really just making up for deficiencies in a lot of these other pieces. And if we think about it that way, I think it'll really start to rethink how we work through the notion of HVAC, and that it's not a solution for, well, I guess it is a solution for bad envelopes, but it shouldn't be. So next slide. The other thing I want you to think about today in the course of your building, which is really an asset, is what elements do you touch in a building, and when do you touch them, and how often, and how do you sequence all those things? I encourage you to kind of draw a line and put dates on it and say, over the next 20 or 30 years, when am I going to have to replace something in my building, right? And think about it totally around the assets. So you might say, boy, that roof is now 20 years old. I might get another 5 years out of it. So I'm going to plop it down at year 5 or so. Boy, those windows, they're leaking. I've got cracks in them. The glazing is shot. We looked at one a couple weeks ago where the films were, somebody had put an aftermarket solar film on it, and that was peeling off, right? And it needed some attention. And so it's like, well, maybe that's something we need to deal with right now. But even things like, oh, I'm going to replace that roof in the building. When I replace that roof, let's say it's a flat roof, am I going to add enough insulation on that roof to make it exceed code? And as I'm thinking about it, can I put a ballasted PV system on top of that? Do I have a roof that can accommodate that? Lighting, we tend to change out lighting like every 10 years in a lot of buildings. And in fact, even with the advances of LEDs, if you haven't redone the lighting in 10 years, even if you have LEDs, it might even make sense to replace that now. Going on the plug loads, if you make a commitment to do like laptops, in 4 or 5 years, you'll have gone through and replaced all of that IT equipment, right? And if you think about it in terms of energy efficiency, and then you say, well, how is that going to then relate to my HVAC? And when do I need to start replacing HVAC? You might have a steam system in your building that's 50, 60 years old, and it's starting to cost you a lot of money to keep pipes repaired and to fix corrosion and things like that. You're like, well, what am I going to do with them? Am I going to keep fixing those pipes? Or, maybe it's really at the end of life and I should think about putting in a lower temperature hydronic system, even if I don't replace the boiler right away. But then when that boiler dies, do I know what I'm going to replace it with? Because when you start making investments along the life cycle, you really want to say, that is the opportunity to be thinking about what's next. And planning for that up front makes a big difference. Next slide. So one of the things that I encourage people to do on their HVAC is, really think about how much that system is running. This was an actual load profile from a project. And you see on the x-axis 100% of design capacity. And the first thing to note is that this system never runs more than 60% of design capacity. Right, so right off the bat, the system is probably oversized by a factor of 2. And there are so few hours that are running between 45 and 60%. You probably could meet those loads by maybe setting up the temperature a little bit earlier in the morning with some preheat. But there are definitely ways that you can think about how to shift those loads. But when you think about this, 90% of the heat in this building is expended at 30% or less of the load. And so if you're thinking about going to a heat pump system, you're like, oh, I've got to try to meet 100% design load. One way to think about that is say, let me put in a heat pump that's only good for 1/3 of the design load. I can make that work economically. I'm going to be running it a lot. It's not quite as big on my electrical infrastructure. In fact, it might match what I'm doing on my cooling side, so it doesn't increase my electrical, and maybe leave a gas boiler for that last 10%, just to kind of do some of those finishing loads on that. But really think through, and if you don't have this kind of data, it's really hard to make that decision. Sometimes it's really easy to collect this. You can go buy a little portable data logger or use an energy management system, but put the portable data logger on, an oil burner or the gas valve and just measure when it's operating, is one strategy to do that. So next slide. And even though that said, heating load, it also kind of applies to the cooling load. So we're going to shift over to Ryan. Ryan has all the answers. So Ryan's going to talk through some of the solutions that we've been working through here.
Thanks, Paul. That was quite the setup. And just since I might not be as familiar of a face to many of you, I just thank you for letting me join. I might be new to the Better Buildings Alliance team as well as Low Carbon Pilot, but I'm not new to NREL and not new to HVAC design and construction community at large. So even though Paul promised I would have all the answers, I think what I want to focus on here over the next few slides is really prompting discussion. So, we're not meant to cover all HVAC system types or complexities or customization. We completely appreciate and understand that the commercial HVAC system space is that unique. And for buildings that perhaps have undergone changes over many years, those systems get added to, maybe space configurations change. So we completely understand that what we'll talk through is not meant to be a checklist for specific building, but really hoping that it prompts discussion towards our Q&A session, so we can hear from you, we can hear your questions, your experiences with regards to retrofit HVAC systems, or as I like to say, we're seeking high performance, beneficial electrification for our HVAC systems. So to kick it off, I think it's important to start by just saying, let's start with rooftop units. Why? Well, rooftop units, they are the most common HVAC system for our commercial buildings here in the US. Now, yes, some building types may not utilize them as frequently as others. Certain size of buildings may warrant, or shapes of buildings may warrant the use of these. But nevertheless, if we look to trying to have meaningful impact and decarbonizing the grid and electrifying building space heating, we can't ignore heat pumps, where they account for over 50% of our commercial space. Now, first and foremost, there's technology, heat pump technology on the market. And there are many commercial HVAC rooftop manufacturers that have heat pump options available. We've noted a few details here for you to take with you, that most of those sizes are less than 30 tons. We've found a few options out there that might be greater than 25 tons. But there are options available on the market today. Now, there was some interesting, I was writing down some notes as the poll was going on, and I might not have done a perfect job, but there was no discussion about or concerns, namely on the performance of heat pumps, which kind of shocked us initially. Heat pumps, the performance of the heat pump for these rooftop units, these package units, they are extracting heat from the outside air to put it into your building. Is fundamentally what they're doing. So there is the reality that the efficiency of these units does go down as they're exposed to colder air. And we actually get that question a lot, like, well, what about the performance? I hear that heat pumps don't perform well. And so, one thing to keep in mind, though, as you're looking at these, yes, their coefficient of performance, their COP might go down. They might be 2 or 1.5 at lower ambient conditions, but that is still 50% or more efficient than just electric resistance. So when we are really looking at this high performance beneficial electrification of HVAC, we really want to choose the most energy efficient option, and heat pumps provide us with the technology that is more efficient than electric resistance, and oftentimes tremendously more, coefficient performance of 3 or more throughout the year. And that's not the only takeaway. There are also challenges with the capacity as a heat pump is exposed to colder air. Its capacity, it's the amount of heat it can provide to a facility, does go down. Now, so we have a couple bits on the slide here to kind of provide reference or thoughts that we can hopefully have further discussion about. But some issues that might arise in that space is, say, the weight issue that is under the key considerations table. If you're trying to accommodate your entire heating load, or maybe it's oversized, as Paul was alluding to on the previous slide, but you're trying to accommodate your entire heating load, it may require a larger rooftop unit in a 1-for-1 replacement scenario that may have weight considerations. For colder climates, this might be more common, at least with the current technologies on the market. And that's similar, in a similar vein, that's also why we provide this idea on the slide here. Well, that might be an instance where a dual fuel heat pump, which is basically a heat pump until it's really cold out, and then you have an auxiliary or backup heating component that could be tied to natural gas to make up for those really cold days. So there's technologies available, and I hopefully, given that this is a very common HVAC system type, this will spark some discussion here later on. Next slide. Another very common, and it's similar to package rooftop units, would be this idea of a split system or a furnace. Some of our light commercial buildings utilize this system. It represents a good chunk of commercial floor space at around 20%. Some key takeaways here is that this is similar to the packaged rooftop discussion on the previous slide, in that heat pump solutions are widely available. for these particular systems. And in this case, often the outdoor unit is not sitting on your roof. Maybe it's outside on a concrete pad. You don't have the same maybe structural considerations you do when you're looking at a one-for-one rooftop unit replacement. So there are options on the table allowing heat pumps. There are also dual fuel options for some of our colder climate applications. And if you aren't aware, there is a cold climate heat pump challenge going on right now, looking currently at residential sized units to try to improve the performance and efficiency of heat pumps for our colder climates. Many of these light commercial applications are almost identical technology, if not sometimes they're the same unit put in a commercial space. So many options on the table. And again, I'll leave it to you that even if the COP is going down, a COP of even 1.5 is 50% better than installing electric resistance as your main source of heating. Next slide. Okay, now we'll get into a few more complex systems again, not to be comprehensive, but hopefully we're getting to system types that are familiar to you or your facilities, or perhaps have brought about challenges in transitioning to heat pumps for space heating in your own planning and action plans set forth to decarbonize your facilities. So that would be what I'm classifying holistically here as hydronic systems. In particular, we're paying attention to space heating, so we're talking about boilers, replacing boilers. We know that a good chunk of commercial buildings utilize boilers for space heating, and these encompass many different HVAC configurations. So the specifics, and that's why I'm not going to go through all the custom strategies, but I want to highlight some of the key takeaways and thoughts, as well as technologies that are there to address some of these high-level designs and system types. Hopefully, it gives you ideas and thoughts for how to address your own needs. Some of those listed here, though, are kind of, I would say, most important with regard to how do we electrify space heating. First thing that comes to mind for hydronic systems for me is the temperature of your hot water heating system. So we've kind of classified a couple different ranges where we say that a traditional boiler system, a traditional high temperature water-based system, so not specifically talking about steam here, but you can imagine that has other challenges as well. But water temperatures on the order of 150 Fahrenheit up to 180, we would classify these as traditional high temperature boiler or hot water heating systems. This was a design standard for many years. And we will get into some topics specifically related to transitioning these systems to lower temperature systems that might offer more opportunities for heat pump or electrification type retrofits. So in that vein, when I'm talking about lower temperature systems, I'm mainly talking about this 110 to 150 degree Fahrenheit range as a general theme. And as you'll see, many heat pumps that are available on the market today can provide heating water in this particular range. Some additional key considerations specifically for hydronic systems is this complexity around, yes, I have a boiler, but what does it serve? And that's here in the list on the slide related to kind of what are your terminal units? Are you using radiators? Are your hydronic loops serving coils, reheat coils, radiant floors, you name it. There's many potential system types and applications out there. And the piping associated with these systems hidden in the walls, but is just as important as the terminals themselves. And so any of these systems that are approaching their end of life, or especially piping systems that maybe once were on this or have been designed for this high temperature application, these offer opportunities for us moving forward to look at changing to lower temperature. Paul's slide that kind of talked about the idea of, does your facility really use the heating capacity that's installed in it? Or has your facility gone through upgrades, envelope upgrades, weatherization over the course of its lifetime to where it has the same heating load that it was originally designed to have? Those can be key questions that we can look at today and work towards transitioning high temperature systems to lower temperature systems without replacing all of the infrastructure that may be there. So next slide. I have a few more kind of topics to provide guidance on and spark conversations around with regard to hydronic systems. These are just generally speaking what's available. So if you're asking, well, what can I do? There are air source and water source heat pump available on the market today for commercial systems. As I alluded, these primarily provide hot water, heating water on that lower temperature range. There's a few exceptions to that, certain refrigerant types, CO2, and some other really nascent technologies and applications where higher temperatures are being achieved. But generally speaking, for our heat pumps, transitioning or utilizing lower temperatures, we have a natural replacement for any boilers or that may be nearing their end of life that are serving these lower temperature systems. Similarly, you may have heard about heat recovery chillers. I've got a couple quick notes on the next slide to kind of provide some guidance there, just as you're thinking about what those are and make sure that we have a kind of a holistic understanding. And lastly, on this slide, maybe you guys have noticed that in all these slides, I've had a bullet point that has persisted over and over, and it has been this last one here. Variable refrigerant flow, ground source heat pump systems. These are options, and these are options for, frankly, most building types, applications out there, but require substantial redesign or renovation of a facility. And I don't like to spend a lot of time talking about those unless a facility is really going through that substantial of a renovation or change. Know that they're there, and we are certainly happy to answer questions about those systems. I didn't want to completely gloss over them because it's not that I don't believe that they are certainly energy efficient options for many applications, but just wanted to point you to that we were focused on some of these more common system types that don't require such extensive of a renovation or replacement that may be more applicable for you if you're looking for equipment that's nearing its end of life. So next slide. Okay, the quick snippets about heat recovery chillers, heat pumps. What are these terms? I think there's a couple key takeaways that I like to share with folks that ask me questions in this space. So first and foremost, let's start with heat recovery chillers. Like, what are they? Well, if you need to remember what these are, you don't have this nice slide deck in front of you for the conversations you're having. Look to the name of the piece of equipment, a heat recovery chiller. So the purpose is, it's a chiller, okay? These are pieces of equipment that are in facilities whose primary purpose is to provide cooling, chilled water. These are chillers. And what we're doing in these particular design strategies is we're taking advantage of the heat that the chiller is extracting from the facility in order to provide chilled water for cooling. We're recovering some of that heat, okay? So this, I like to share that this is warm water, okay? Most often, this is warm water in the sense of what can we be using this heat that we've recovered for? There's many applications where this is very beneficial. You have high cooling loads, consistent cooling loads that provide you with opportunity to recover consistent amount of heat. You could use that for preheating strategies. You could use this for preheating domestic hot water strategies. There are a number of applications that make this technology beneficial. But I want to just draw the difference here between what is a heat recovery chiller and what are these heat pumps we're talking about in today's discussion, where we're trying to transfer the building's heating load once served by boilers or some other means into an electric resource via heat pump. And that's the main difference. Heat pumps, these are designed for heating. Okay, these make hot water. I tried to make this slide easy to remember, easy to take with you. But this is the primary purpose behind these is to generate the hot water. And that makes the use of these technologies distinct. And so as you're envisioning what a plan might be for electrifying your particular building or various assets, it's important to consider how is the building currently using energy today There may be opportunities where heat recovery chillers help shave off some load that might be domestic hot water load or some other preheating load, but ultimately to address the primary need for replacing fuel-fired space heating technologies with energy-efficient electric technologies, heat pumps is going to be our primary avenue and technology to serve that purpose. Next slide. Okay, a few quick notes on some emerging technologies and ideas, again, in hopes that it sparks conversations and questions, which I haven't been tracking carefully yet. So if questions are coming to mind and you want to ask, drop those in that question pane that's right next to the polls we were doing earlier. And then we can, both Paul and I can address any questions you have related to these technologies or perhaps others. But nevertheless, in the space of hydronic heating systems, there are some emerging technologies. I just wanted to point out generically a couple. There's a lot of modular heat pump options available on the market today. So these modular, it's like a small package unit that you can pair multiple of these side by side to serve your heating load. So different from going out and buying, one really big boiler or two because you want some redundancy. These modular pieces of equipment allow you to pair multiple same size pieces of equipment together. This serves a lot of use. They can be staged to improve performance. It allows some considerations around defrost cycles for heat pumps, things of that nature, where you can have a redundant or one unit always in defrost. So there's lots of benefits to the modularity of these sorts of systems that we certainly want to share and bring to your attention. Similarly, there are emerging technologies and these modular systems that also offer kind of a simultaneous cooling or chilled water on one side, as well as heat pump hot water on the other to serve simultaneous heating and cooling needs, as well as opportunities to perhaps share some of that resource. And so some of these technologies are coming on the market, and we'd be happy to either have some discussions today or, of course, point you to additional resources at any point after this particular presentation and call. And lastly, I think I'm going to say it for my second time, and it might be the third time you've heard it in today's presentation. We find that many of our existing buildings today had their original heating equipment and heat load performed at the beginning of the building's original design, before it was constructed. As Paul alluded to with this timeline for buildings will inevitably go through many upgrades and changes over the course of their life cycle. And through that, whether it be the new roof, and when the new roof was created, and so it was brought up to the current insulation codes of that era. Nevertheless, oftentimes we find that for our heating systems, we haven't revisited the sizing. When we go to replace equipment, we look at the nameplate, we try to find as close to one-for-one replacement as we can. When we're doing these upgrades that are impacting envelopes, that are impacting the potential heat load for our building, it's creating a pathway, a direction for us to consider, well, if I'm lowering my heating load, like a few slides back where we showed that particular example building site, do I really need the nameplate heating capacity that I have in my boiler room? If I don't, it changes the options on the table for me. Not only does it mean I can buy a smaller piece of primary equipment, sure, but if my old system was on the higher temperature range, okay, to where heat pumps aren't always able to generate 180 degree Fahrenheit water, well, if my heat load has come down enough to where I can provide the new heating load of my building today, even using the same piping infrastructure, the hydronic infrastructure, some of the coils at a lower temperature, if I can begin looking at that, then my pathway to decarbonizing my heating load, we have more options. So really looking at that heating load, looking for opportunities where we can get to a lower temperature system, both of those are critical in transitioning to the use of heat pumps in the future. So I kind of wanted to harp on that one more time, just because I think it's an important takeaway and something we see very often in communicating and discussing with stakeholders in the industry. But there's often opportunity to do exactly what I just said, even if you are challenge me today to say, well, I've got this system, it's 180 degrees, 160-degree return. I don't want to change all my piping. Well, wait a minute. There may be opportunities for us to look at that more closely and say, hey, can we start transitioning this to lower temperature? Can we start replacing equipment during tenant improvement fit outs to lower temperatures for a future change of the entire system down the road? And that's sort of an important takeaway we wanted to provide everyone here. Next slide. This is quick. Again, I did not give you all the answers, nor did I give you all the technical resources. In this slide deck, there are a number of resources we'd like to draw your attention to so that you can take with you and read further detail, more information, maybe even more specifics related to your individual system. So they're here and we just want to make you aware of them.